thank you for joining this session. Yes, a bit of a break from the S-Bond security. I don't know why this talk is in the security track, but hey, we are here, and there is actually something about security that concerns eBPF, so we'll talk about it in a bit. So, first of all, I am Alessandro, so I'm here on behalf of my esteemed colleague Rohit, because Rohit couldn't make it because of visa problems, so he asked me to step in and be here on his behalf. So I would like to introduce you to Rohit. He's a developer advocate at Solo.io, a company that I just joined. And he's a very enthusiastic guy, and I'm so sorry that he couldn't be here, and I feel like we owe him because he was really excited to be here, but unfortunately there was some problem with the visa and he couldn't make it, so hopefully maybe next time. So this is Rohit. He's very active, he has a bunch of communities, he's very enthusiastic about this DevRel thing, and he's really, you should check him. He runs this community where you can share your experience about developer relations, and it's just a very, very cool guy. And because we co-present, so he should physically be here, but he can't. So I have some parts where I'm gonna talk. I'm gonna talk about the eBPF, of course, and some parts he recorded some videos for us, and then I'll show it to you. But I'm here to answer any question if there's any doubts, or you can check with me later. That's me instead. So I'm just a very fresh developer advocate. I just joined Solo a couple of months ago, so I'm really excited to start talking in public more and more. And I'm also organizing the Dutch Kubernetes meetup. So I'm a CNCF ambassador, although CNCF ambassador are no more, so I used to be, and I run the Dutch, of course, the community, and also the KCD, the Kubernetes Community Day at Amsterdam, which is a very interesting conference. It's happening in 2 weeks. So again, if you like to visit Amsterdam, if you want to engage with the Dutch community, ping me or talk to me. We love to have people over, and maybe one day we'll have something like this, but in the Netherlands. It's my dream. So I work at Solo.io. It's a very, very dynamic young company. It's a startup. We are about 200 people, but we are really all focused on service mesh. So we are the company behind Glue, which is an enterprise version of Istio, and we extend it with multi-cluster and federation and all sorts of magic stuff that I'll be very happy to discuss with you. This is not the focus of today, but definitely something that we can discuss. And yes, we are hiring, of course, still, even in this climate. But also, because we are so concerned with application networking, and we do quite a lot with enhancing what programs can do in a cloud-native environment, right? So at some point we also encounter eBPF, right? So we look at Cilium, and of course, like everything I'm saying today, I saw that, of course, before me yesterday there was the great talk from Liz, and I mean, she wrote the book on eBPF, and she's great. And of course, I hope you were following that talk, so you got some introduction to eBPF. I'm not gonna go through the whole story. Of course, eBPF is a very large topic. There are even books written about it. It's been around for quite a long time. So I'm just gonna show you what we did Solo to make you write eBPF program a bit easier, right? So something a bit more streamlined, we improve the user experience, so to say. So eBPF, I'm 46. I was there when Linux was released. I wasn't there in 1992. I was just a kid. But I remember when eBPF was released in 2014. And so I remember there was this movement of enhancing the original Berkeley packet filter, who was born just to intercept network calls and do something with it, with eBPF, right, with the extended Berkeley packet filter in 2014. So what it is it's a way to to work with the kernel in a sandbox environment, so without really decreasing the security or be more secure in interacting with the kernel. And it's a way to run programs that can interact with the kernel space in user space. And so you can be very close to the kernel in terms of performance and in terms of what you can see from the kernel, but still keep it very, very safe and very isolated from the rest of the programs running on the same kernel. So there's a foundation around it, so it's so important. It's an important piece of modern networking, base of Cilium and base of many other tools out there, which, well, we're going to talk about one specific tool, which is Bumblebee. So what it is, it's a way to execute this custom logic, custom programs in the Linux kernel without affecting the whole machine, the whole host. So it works with hooks, right? So we hook into the Linux kernel to the eBPF, and we collect data, and then we store the data in some specific data structures, hash maps, ring buffers. We'll talk about it, and we use that data later in a user space program. So it's a way to extract information from the kernel and do something with it, right? So this is, and also you can write back to the kernel. You can modify or do some packet processing or applying policies at the kernel level. So it's extremely performant and it's very convenient because everyone runs a Linux kernel. So that's exactly where you want to operate when you want to have performance and security. So use cases, of course, security. So intercepting syscalls is the base of many security tools like sysdig, Falco, and other ones, where you can see what's going on, intercept, because everything has to be a syscall in Linux, right? So everything has to go through the kernel to interact with the network stack or with the disk, with the I/O stack, right? So syscalls are where you can plug in and see what's going on, right? So, and that's exactly what eBPF can do. It gives you a hook where you can collect data and work the security of the system. So you can see which process writes which file and be alerted when something happens. There's a whole security plethora of tools around eBPF. So traceability profiling is very close use case. Of course, you can see if a process is consuming too much or what the consumption of a process can be. Networking, very important, so you can see everything that goes through the kernel, everything that goes through the network stack of the kernel, so you can see who calls who, you can see the packet drops and so on. Everything that is coming from the network stack, the network interface, you can collect from with eBPF programs. It's really just very powerful way to have a very deep overview on what's going on a host. Of course, also, and that's the topic we're going to talk about, it's observability and monitoring. So getting all this data, export them somehow into a format that we all understand. In this case, we're going to show that you can use Prometheus metrics format, and then collect them and show them to your users. So the high-level architecture, of course, you all start from the kernel. So the kernel is what runs on the host, is the interface between the user space and the hardware underlying. Surely this is most of the time a Linux host, but surely Microsoft engineers and others that work on porting eBPF to Windows. So this is not only a Linux-only game today. There's also a way to run it in Windows. It's in development, but it's something that it's important because then you have one unified way to look at kernels, no matter if they are Linux or Windows. So this is how it works. So you write a eBPF program that interface with the kernel runtime, and then it shows you or exports this data up to your tool in this case, for example, Cilium, Falco, and the one we're going to talk about today, which is Bumblebee. So this is, again, so it's not I'm not going to give you the whole story about the eBPF. It's people better than me, of course, talk about it. But in general, like you write a user program that is always verified by the kernel. So there's a hook that verifies if your program is safe to execute, and then execute these hooks like kprobes, uprobes, and trace points where you can collect the data and then send it back through these maps that we talk about. So let's say that you want to write a eBPF program, and you have a few choices. So the first choice, the one that most people start with, of course, is the BPF compiler collection, which is a Python wrapper around your BPF programs. It works. It's just a bit clunky. Of course, you have to know Python. You have to embed your eBPF program inside as a text file, as a text structure into your Python code. So it's not exactly the best user experience out there. And we'll show in a second why it's not that great. So, of course, you also need a lot of extra stuff, kernel headers, Python, knowledge of Python. So you have to write your user space and your kernel program together. So it's a bit, it requires a bit more steps than what we would like to do, right? So, and it compiles and it creates this binary that can be executed. So the next step, which we'll show you in a second, is to use libbpf, which is has introduced this concept of compile once, run everywhere. So where you compile a program that can be run anywhere you want. So you compile it, you can port it to another host and run it there. So it's a bit more portable. It gives you a bit more flexibility in what you need to provide to compile the program. So, but like a demo runs, it explains much better. So this is Rohit, and I want him to be
After that,
virtually
let's
here.
start with today's demo, where we are not going to do any different kind of a thing, but here just I will show you like how the Python code and how the code is TCP connect, which you use like TCP dump in your laptop, right? So where you see the IPs and addresses once the TCP dump is used. So here we are when it was a BPF compiler collection code. So what happens? You have to write it in Python and C kind of a thing. So here we are just using the TCP connect file where we are running the same thing and we are getting the output like various websites running on my laptop system. So similarly, as you see, there is source and destination IP address for all communications. So let's see what is going on inside that file. So here you can see the beauty of the program. So here, as you can see, there is a C language code is written here. Yeah, see. Till here you can see like C language code is written, but it is really complex and really tough. Like I'm not that much expert kind of thing, right? So after that there is Python level code also, right? So when you are writing the two codes in the one program, there is like different issues you can face because C program is embedded into the Python code. So what happens during this stuff, you can see the program is small, but it's not easy to understand. It relies on various naming conventions. And when there is a various naming convention, you know like what can happen because you have to target it to various things and trace it and stuff. So yeah. So second part is like user space program, which we discussed at the top below. So BCC works, but it has a lot of limitations, as we told, like heavy resource utilization and dependencies on kernel headers, which we have to track it and kind of thing. There is a really complex debugging here. So what can we do? So why the eBPF is trendiest, and why it was discussed a lot during last year's, right? Last KubeCon and stuff. So to overcome these limitations, libpf and BPF core took a different approach. What they did. So now you can write entire code in just a C language. You don't have to write the different code. And that C language code is written in such a manner like you can compile once and you can run anywhere. So to show that, we will just move to the different directory, and these files are available, right? Here you can go and you can check that files. So after that, you can copy these files, and we just have to make. So if you are from the sysadmin and DevOps background, you should know like what happens when we do the make. It will generate, it will combine the files, and it will make compilation. So once that is done, we will just use that TCP connect to run, and you can see the similar output, whatever IP and destination IPs were running in my system, it will reflect. So it is so nice, right? So I don't want to waste your time, and I will directly show you the what it goes inside that BPF code. So as you can see, everything is running in the C language code now. So such a beauty, right? As you can see here, like we have the one thing you should notice, like it is everything in the struct. So after that, I will also show you. Yeah, that I will show you by the command. But struct, as you can see, here is the first interesting part. This defines a BPF map of type hash map. So here you should see that max entries one here only. So yeah. So as you can see, there are two main types of maps available, which you know, like ring buffer and hash maps. But we are using the hash maps in here to store data and some key references, because it does not function as a queue. So it has a traditional map where you can map your keys and values however you want, and it will be there until you remove it. So another section to discuss is that K-prop. So this is like everyone asks like what is K-prop and that kind of thing. So you can go and learn it deep wise, like what it is. Nothing, just it is one kind of a thing where you can connect the eBPF with the your TCP and networking layers. So as you can see, this defines a K-prop that will attach to the TCP connect. And let's look out to the source code of the user space application. So you can also view that, and inside that you will see like there is some print count IPv4 function. Yeah, here, and inside that, as you can see, there is different source address, and that key value mapping is not kind of thing, but yeah. Other than that, you can see how the user space application gets its data from the eBPF program. So we are just assigning that values taken from the Cubase and assigning here. So and you can simply copy the TCP connect binary and execute it on any other machine. So once you get that binary file, you can take it and use it anywhere you want. So that's why it is like compile once and run everywhere. So what if we could only write the BPF program, right? It will be really beautiful kind of thing, right? So let's go ahead and move to our next.
All right. So as you saw, the first one with BCC, you have to do Python and then execute your user space program, and of course with libBPF you can compile and it works just fine. So, okay. So now we want to improve the user experience, right? So I don't want to write complicated user space programs. I want to just focus on the kernel side, on the eBPF program. So that's why we, as Solo, they came out with this Bumblebee project, which was an internal tool that then they decided to open source, and then to simplify the building of these programs and the management of this eBPF program. So what the idea of Bumblebee is that you use it like you use Docker. You do Bumblebee build, Bumblebee B, which is the command line, push, so it generates OCI compliant images that contains your program, and then you do brun to run your program. And you also have binit, which scaffolds your project. So it's pretty convenient, and if you can think of these eBPF programs like you think of Docker images as OCI compliant, then it becomes much easier. You can just push them to any registry and let somebody else pull it and run it. So that's exactly what this project aims to achieve. So, and there's another demo. Sorry, it's a shorter one.
So you can get it from the open source GitHub repository also, but here we will just run that command similar to that. Use the export whichever terminal you want. Once that is done, as you can see, we will do the binit like Terraform init, and it will initialize everything. So it is in the C language, but we are planning to make it in the more languages like Rust. After that, we will go with the network type for this initialization. After that, we are using the hash map because as we discussed, like we want more convenient kind of a thing. So after that, we will go with the print, I guess. Let me check also. Yeah. So we have to just mention this probe.c program file location. Once that is done, you can directly visualize what generated and kind of a thing. Right. Sorry. So let's do the cat probe.c, and then you can see this inside that. So as you can see, everything is there, and now I will show you the beautiful part. Like everywhere there is a counter. So what is a counter, right? So here you can check, like we will use the diff to see the differences between the your say TCP connect and Bumblebee code, right? So there is just a counter. So it is using that counter to suffix to let Bumblebee know like how to interpret it on the user space. So it is really beautiful, right? So let's copy the updated version. After that, we will build it like a Docker. We will build it, and you will see like it has the same naming conventions kind of a thing. It is using the local host and so IP kind of a thing, and then image name and version like tag. It is really easy way we have created. It's like it is built on the open source, so you can use it anytime. So as you can see, yeah, we have just pushed it, and now we can run it however we want. You can see here. So once it is running, let's do the curl to check the metrics. You can see like metrics are generated because the traffic is creating here, and it is increasing the values, hash values and stuff. So as you can see, Bumblebee also provides metrics in the Prometheus formats. So we already generated that, and now you can use this Prometheus metrics wherever you want, right? Really convenient kind of a thing. So
okay, so if you see binit gives you this initial program that you can just use for your to start a project, and it's quite convenient, right? So you can use it to quickly put together a eBPF program. And you see, so there is actually on this machine. By the way, these labs are on academy.so.io, so they're free, they're based on Instruct. So in the Instruct virtual machine, there is actually a Docker registry running as a Docker process, so that's why the Docker push localhost. But you see, it's like exactly what I said. It's you build this, you compile, and you build this eBPF program in a OCI registry compliant image, and then you push it and you run it. So that's very simple. So where you go from there, of course, this is Kubernetes Observability with eBPF. So let's see how you integrate this actually with Kubernetes, right? So how do you run this in your cluster? So this is what we're gonna create, more or less. Again, these all instructions are available. So we're gonna deploy a demo application and then a daemon set that will run exactly the same program that we built, but this time as a daemon set on every node. So because it runs on every node, you can clearly gather and collect all these Prometheus metrics and show it. We also build this eBPF, which is a visualization tool for eBPF. So this is the last one. So that's good because we got 5 minutes. This is 3 minutes, so that's great.
As whatever I told you, so let's apply that application, sample book info application. After that, we will see like pods is running or not. It is containers are creating, everything slowly. So everything is not on the same nodes. Different nodes are there, and after that we will just create the namespace as a Prometheus. Prometheus namespace is created. Every time I recommend everyone to create the environment and namespace every time you are working in the cloud native world. So after that we are just using the Helm charts to add the Prometheus. So it is available in the GitHub repository for the Prometheus only also, right? You can use from that. So what this code is about. So we have created a Docker image with a Bumblebee. We will run it in each Kubernetes node to load our TCP connect eBPF program and gather the information about all communications happening in the cluster. So it is just like getting the metrics, how your application is interacting with the eBPF kind. So let's do that thing. We have created our demonstrate app only. With that,
let me just grab your attention on you see, so this is a Docker image that contains the B executable, and as a parameters, you point to the local registry, is on the master node, of course. So the image will pull the eBPF program from the registry and run it on every node. So the image that we built is not a Docker image, just a OCI image that contains the eBPF program, while this is a Docker image that contains the B executable. Okay, so let's keep it to where we were.
With that, so remember, like master is the host name for our VM where the registry is running. So as you see, pod monitor monitoring ports have been created. So let's generate some traffic to see the beautiful things afterwards, right? So it will show you. Yeah, it is creating. So we now have all the metrics captured by our eBPF program and stored in the Prometheus, like we generated last time, right? So same thing we will do. But source IP address corresponded to the pod IP address and destination IP address correspond to the server cluster IP address. So that kind of application we will create now using the eBPF to gather the metrics from Prometheus, and we will see the dashboard also, right? So we will first create the RBAC kind of thing, cluster role binding. So as you see, cluster role binding is created, authorized, and we can now deploy our eBPF. Yeah, service account is created, deployment apps, service are created. And now, as the diagram below shows how all the components work together as I discussed here. So here you can see this thing we have done now, and this is the interaction. So let's see like we have created or not. And these codes are available, right? You can take it from here, you can copy paste and pasting. This workshop is also available on our Solo Academy. You can go check it there. So let's see. what is generated. Yeah, as you can see, beautiful dashboards is here. You can play with it. You can do various things, and you can see like Prometheus metrics are generated from here, and there is a metric server, and similarly, as you can see, your product page, your reviews, ratings, and that kind of thing. And this was the left part in our diagram here. This is that, and this is right one. So really beautiful, right? I guess I solved your doubts, and really glad to see that. So yeah, we have next things coming up.
Okay, so this is exactly what we aim to build, like a observability stack built with just a few lines of code and just a few things running on your, and a daemon set running on your node. What's next? Of course, an operator to facilitate the whole deployment, support for Rust and Golang is in the works. And of course, like you can join our Slack where we can discuss these things. There's a Bumblebee channel there. We just opened an ambassador program for Solo.io, so please, if you want to be part of the fun, you can join. You can come to talk to me. Solo Academy, academy.solo.io. You can find this and many more of these tutorials, so you can just follow them and see for yourself. And thank you very much. And if there is any question, I'm here for everybody. Thank you.